Hello, and welcome to Iterating on and Evaluating Production-Ready RAG Applications with Gemini and W&B Weave. Today's webinar is sponsored by Weights and Biases and Google Cloud and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech, and I'm excited to be your moderator for this special event. Now, before we get to today's great session, we do have a few housekeeping items that are going to help you get the most out of this event. So first off, we want this to be an informative event for you, so we encourage any questions in the questions box in your webinar control panel. Not only will we have team members responding to questions during the live event, excuse me, but we'll also have a dedicated Q&A session at the end of the presentation where we'll discuss in greater detail some of the top questions that you ask. The Q&A panel is also the place to let us know about any technical issues that you might be experiencing. A browser refresh will fix most audio, video, or slide advancement issues. But if that doesn't work, just let us know in the Q&A and we'll provide further technical assistance. Now, second, in the handout section of your webinar control panel, you'll find that we're offering several resources. I'd especially like to call your attention to a few links there. There's one to check out weights and biases in the Google Cloud Marketplace. There's a link to a free course on LLM engineering about evaluation. And then there's a link for insights using Google Gemini and weights and biases. So I highly recommend all those resources. You can access them throughout the event. And feel free to share them with your friends and colleagues. Now, third, at the end of this webinar event, we'll be awarding a $250 Amazon gift card to one lucky registrant. Of course, you must be in attendance during the live event to qualify for that prize. Official terms and conditions of today's prize drawing can be found in the handout section. Just scroll to the bottom and you'll find the link with the details there. And finally, one of the best benefits of this event is the opportunity to ask a question of our expert presenter. So to help encourage your questions, we have a special additional prize for you. That's another Amazon gift card, this one for $50 for the best question. So after the event is over, we'll look at all the questions that came in, pick out the very best one, and contact that prize winner. Okay, with that housekeeping out of the way, let's get to today's fantastic session. It is my pleasure to introduce you to our presenter today, Anish Shah, an ML engineer with Weights and Biases. Anish, welcome. Thanks for being here.
Thanks, Scott. So I am Anish. I work at Weights and Biases as an ML engineer who builds really cool and interesting projects to educate the community, like all of you here. So I'm really excited to talk about a topic near and dear to my heart, which is about productionizing RAG applications, especially in this world of AI where things are moving extremely quickly and lots of terms are being thrown down. I want to make sure that you, one, understand what these AI engineers are actually building in a practical perspective, and also understand how they're transitioning it to these end users and utilizing tools like Weights and Biases and Google Cloud to do all those different workflows. So there's a lot of information to talk about, so let's jump right in. Next slide. Cool. So first, some housekeeping about Weights and Biases. So what you see here is our developer platform. So for us, our perspective is that Weights and Biases models helps a large collection of foundational model builders across multiple domains, be it legal, healthcare, finance, or even high tech, to go ahead and build these AI models that you all want to use downstream to build your Gen AI and AI applications. And so our new perspective we just added in is Weights and Biases Weave, which we'll learn about a lot today, which is our new tooling for evaluating and monitoring Gen AI applications and agents so you can take that transitionary POC that you're making using AI and actually put it into the hands of end users and customers in whatever product you want to embed it in. And to help enable all these different tooling, we interplay really nicely with Google Cloud. So not only are we in the traditional model space where those really smart ML engineers are building those large scale models like Gemini, we ensure that we work with Google Cloud so that all the tooling necessary to make a satisfactory decision about releasing Gemini 1.0 to Gemini 1.5 can actually happen in a scientific and streamlined way using a variety of tools such as artifacts, tables, experiments, and etc. And more than that, We also ensure that when you are ready to use those end tools, such as Gemini 1.5 Flash and 1.5 Pro, which we'll see here today, we also ensure that Google Cloud and Weights and Biases interplay really nicely with some native integrations. So when you do deploy these models on Vertex or the Google Generative GenAI SDKs, you can easily plug that into the tooling to ensure that you can confidently say that these end AI products you're releasing to customers are of high quality, high correctness, unbiased, and unhallucinated. If some of these words don't make sense to you, don't worry. We're going to jump right in and show you exactly how Google AI, Gemini, and Weights and Biases Weave all interplay together to really make those really useful applications that we see. Okay, so first things first is to understand the difference between software tooling and AI tooling. So software development is a very linear process. You write code that works, and if the code passes tests, then you know that it's a successful piece of code. Those tests represent those specific edge cases that software engineers are considering. But in the world of AI, especially in Gen AI development, you actually know that learning is what your actual IP is. So not are you going in and understanding that you're jumping in and just releasing code. What you're actually doing is you're testing out a bunch of different workflows and a bunch of different data sets, configurations, and etc. before coming to a conclusion based on a hypothesis. So remember, don't forget about science class, to actually make a decision about what is the appropriate release in this situation. And as a result, in the world of software development, your code is your IP, but in the world of AI, your learning is your IP. So you can actually go and provide to end users the proof that this is an effective application. So transparently, it's a lot more annoying, but a lot more fun as a result, at least as someone who enjoyed science class quite a lot. And so we're not the only ones thinking about this perspective, how to use AI in interesting ways. There are many foundational model builders, people in high technology, healthcare, autonomous vehicles, and retail and financial services who also see value in AI and are working on building applications like the one I'm going to talk about now. So without further ado, feel free to scan the QR code if you want to have access to some of the code that we see here. But we're going to be talking about how to use Weights and Biases and Gemini to actually build RAG applications. So for those of you who aren't really aware of what RAG is, this is a really nice graphic I quite like that shows off what RAG actually means. So RAG is retrieval augmented generation. So it's this concept, quite simply, that you hook up your foundation model, so your Gemini, for instance, with access to a search engine. So a search engine could be the internet, or it could be your own proprietary database within some fancy terms that you heard, like such as vector store, which actually have a connection to your proprietary data. So for instance, if you're in the world of finance, for instance, which we'll be talking about in this specific code when I walk through some code later, in the world of finance, that could be access to specific SEC filings, for instance, that your company has been collecting over multiple years, for instance, for multiple corporations, that you want to have access to your internal traders, for instance, who want to actually make key decisions about which companies are worth investigating more about or asking very specific questions about. In any business, you can also see this. So in the world of healthcare, for instance, you can also imagine that you can hook up, once you have you have everything nicely squared away in your Google Cloud environment where everything's nice and air-gapped, you can put in, for instance, patient-doctor dialogue and ask questions about, hey, I talked to this patient 3 weeks ago. Gemini, can you go in and grab the latest patient interaction with this patient and that one from 3 weeks ago and see if there's improvement from that dialogue? Those are all situations that you can present. And so the concept is RAG, and it's up to you to determine how you actually release that publicly to the world, for instance. So for some of you, that could be an endpoint that users can interact with, similar to similar when you log into Google Cloud and can interact with Gemini from the chatbot, for instance, or it can be internal, depending on how you actually want to plug it in to the rest of your software stack. RAG is one piece of the puzzle. It's still up to you to determine how RAG can be used in your product. But once you're actually ready to take it to the next step, you know what? Actually, let's have a little bit of fun. Let's actually go and run some code right now. Let's run through a basic RAG pipeline using Google Gemini and investigate how well that pipeline is actually working. So I'm going to actually share my screen now, this screen here. So Scott, let me know if we can pop that on right now.
Yep, we see it, Anish.
Cool. Awesome, thank you. So you can see here that there's a lot of code going on. We're going to ignore most of it. So I'm just going to run through this and walk through kind of the basics and how it relates to the slides I just showed in that graphic. So after setting some Gemini API keys and W&B API keys, Gemini with a very generous free tier for those of you who want to run this notebook, for instance, what we'll do is instantiate this project. This project just means that every time we talk to Gemini, we're going to store this interaction, this platform, so we can go and actually understand what's going on as the LM is thinking about the document we just provided to it. Then what we're going to do is just load in some documents to look at. In this case, these are some PDFs about SCC filings. Let's see if we can actually go in and just look at a document, for instance. This is stored in data, finance docs, and let's look at Apple. This does not look that good. Okay, so I won't be rendering this. We'll look at it from the weights and biases side to make it a little bit easier. But in essence, what we'll see is that this is a very large document, which is a PDF that we can use. And so there's some code to process this in a really efficient way. So I'm going to actually show you what that looks like here. It opened in the screen. Lovely. So we're going to move this to... Oh. Sorry. Okay, cool. So you can see here that this is like a document that you can see. If we can scroll through on the side here, which is being slightly covered right now, we can see that's this very large document, and it contains a lot of tables and figures and just information about Apple in 2022, for instance. But for us, what we kind of care about is how we can utilize this information so that I, as a human who doesn't know this information but wants to analyze aspects of this, can have Gemini actually do the thinking for us. So what we can next do is actually do that component. So this document, although now in the modern form of Gemini could probably process this whole large PDF, we're going to be smart about it and say that, like a human, it's better to ingest things in bite-sized ways. So we're going to give small chunks of information to Gemini, where each chunk is actually a useful component to the question I'm asking. And so there are really interesting ways in the data science and machine learning world to process this. We're just going to simply take snippets of the information and just shove that into Gemini. And then we're going to do this in a really efficient way so that when we ask a question to Gemini, it's able to dynamically understand what that question is and retrieve the most useful information to use. And that's what's kind of happening behind the scenes here. Just take my word for it. And that's the concept of vectorizing this data. And that's that portion we see here under retrieval in that graphic I showed earlier. And then afterwards, so you can see there's some fancy code that kind of represents how we're able to retrieve that information in this vectorized form. So vectorized just means turning text into numbers, so numbers can represent what the actual chunk of information means. And afterwards, what we're going to do is actually ask that question. And what's nice is that because we stored this in a really mathematically performant way, in a way that Gemini was able to process this, we're able to actually now, every single time we ask a question such as, how has Apple's total net sales changed over time? We're only grabbing the most useful information from each PDF to then pass over to Gemini again to solve that question. So if I were to ask this question, how has Apple's total net sales changed over time to Gemini now? There's a problem of limited understanding from Gemini because Gemini has been trained up to a certain point. So there's a cutoff of what Gemini is able to know. RAG solves that problem by simply saying, I'm going to tell you by providing that raw chunk of information to Gemini to actually go and read that new information that Gemini may have not been aware of, and now use that to answer this question. So the concept of RAG, like I said, is essentially just shoving information that makes the most sense to your end user's question so that the large language model, Gemini, is able to actually answer that question. So altogether, skipping a bit ahead, once we combine all the pieces together, what we'll see is something like this. It keeps opening in a different browser, which is unfortunate. Which looks something like this. And this will actually clarify the workflow that I'm talking about. So if I were to make this a bit bigger, you can see that there's a couple steps that I mentioned. What I did here is, first, I retrieved all the most important documents. So like I said, in this situation, the question we asked was, let me full screen this, was how has Apple's revenue from iPhone sales fluctuated across quarters? So this will do is now retrieve documents specifically about iPhone. So all of these will say something like, during the first 9 months of 2023, the Japan net sales decrease consisted primarily of lower net sales of iPhone. So something relevant to the iPhone sales across quarters. Same type of chunk from 2023 Q1 to 2023 Q3, Q1, and also Q2. And all of these talk about the net sales of iPhone. So from the whole PDF, we were able to only extract those useful pieces, and then we actually just shoved those pieces directly into Gemini. So over here, if we open up this trace tree, as we call it, oh, the page is now loading strangely. We love live demos. Hello, what is happening? Oh, that's unfortunate. Okay. That's fine. Take it a second. And so while this is, so perfect. Now it's able to open up. Cool, awesome. So this says the word light LLM. Light LLM is just a way to easily swap between models really easily. But you can see here that we're using Gemini 1.5 Flash. And what we did is we just shoved in all of this text right here. Sorry, all of this giant green box over here into Gemini. At the very bottom, ask the question, how was Apple's revenue from iPhone sales fluctuated across quarters? And because of that, now we're able to have Gemini go ahead and look at each component from across different quarters for this Apple PDF and actually answer that question and make a very streamlined decision about how those sales actually fluctuated from quarter to quarter. So to kind of reiterate, there's a process of retrieving the most useful information from our own dynamic search engine that is contextual based on whatever user query comes in, and also providing that information directly to Gemini to read that information and answer that question. And so what's useful here is that RAG can be grown continuously, which is what makes it a slightly better process than something like fine-tuning, for instance, where you would have to go ahead and actually have data provided to a large language model, and then its cutoff is now wherever that information also ends. RAG can continuously grow because what you're doing is just increasing the amount of pages in your search engine in general. And so what makes RAG useful is that it doesn't necessarily have to be all in or nothing. You have a lot of interesting ways to iterate on RAG. So I'm going to now stop sharing screen and continue from here. So this right here, what I showed you, was actually just a very basic example. If I actually jumped in and dived in deeper on the answer that was provided by Gemini, there's actually a bit of flaws here and there in formatting and in general, a lot of other problems with just the quality of the answer as someone as a financial expert may consider it. And so that's where we're able to come in and make adjustments by continuously iterating on RAG. So to show that here, this is what a more advanced production-ready RAG pipeline looks in here. So RAG can be as many layers as you want it. You can have multiple layers of interactions with Gemini, for instance. You have multiple layers of how you enhance the question coming in from the user by truly understanding what they want, or even determining what the best documents actually are and throwing away a bit of the distracting fluff that Gemini may try to read and get confused about as a human would. So let's go through and iterate on some of these pipelines. So from our own internal usage of these RAG pipelines, we actually have our own deployed version of a weights and biases bot that we call WandBot that is able to answer domain-specific questions about our platform that isn't known to Gemini right off the bat, as our SDK and our own tooling continuously upgrades. We release new examples, new software patches, and new releases. And so what we do is just make that available to Gemini in our search engine context that I've been mentioning. So that vector database, that optimized search engine. And so what makes RAG kind of difficult is that it suffers from a lot of the same issues that you see from foundation models. So there's inaccurate responses, privacy concerns, and a lack of that human touch. And at the same time, the more that we're able to iterate on these types of workflows, we're able to actually increase things such as CSAT if you're using a chatbot context for answering customer queries, for instance. Or we're able to choose better models so we can save costs. And we're able to actually be really smart about how we're able to dynamically switch between models and have very highly performant databases, for instance, that we're caching efficiently to have 24/7 availability. And that can all plug in to a lot of the Google Cloud tooling that exists there, because there are great tools to make optimized databases, good virtual machines that are able to dynamically switch between deployed Vertex models, for instance. So there's a lot of ways to balance the evaluation piece powered by weights and biases, but also have all the components and tooling also from the Google Cloud side. So in general, to iterate effectively on RAG situations, you want to treat it like every other scientific process. So start with a clear use case and success metrics. You want to ensure that you have high quality data. So that comes from that end user mining, for instance. And you want to adopt an evaluation driven development approach. So you actually want to release a early version of the application that domain experts in your own team or field can utilize and use that to create that high quality data, and then develop a robust evaluation framework that represents how those users are actually thinking about using that application. And so another step to actually help this is that because the human labor cost of actually jumping in and evaluating a lot of the quality of these workflows is difficult, you want to have a nice balance between automation and human oversight. And so there's a concept called alignment, which I won't touch upon here, but that does exist to help you ensure that you can take a lot of the domain experts that are looking at the answers of your RAG application, ensuring they're of high quality, and then building your own automated tests around this. So as you release your new versions of your RAG pipeline, or as you experiment with your RAG pipeline in the ways I'm going to show you next, you're able to say confidently that this makes sense and my quality did increase. And that inherently, it maintains a version of transparency and explainability, because you can jump in and say that my recent experiment where I adjusted maybe the type of database I use or change the prompt that actually is solving the question coming in from that search engine page actually is of high quality. So let's go through and look at how we're able to address some of the challenges with our own solutions. And so in this case, what we're able to do is, because we have this evaluation-driven approach, we can adapt to rapidly changing LLM APIs, ensure that we balance improvements and fixes alongside these large changes, and have nice representative data sets. Sorry, my screen flashed for a second. And so I'll walk through that in these next slides here. Let's just jump through and actually look at some evaluation strategies. So as we saw earlier, RAG pipeline can be really simplified to a couple components. So you have a query coming in from the user, so that question that actually is being answered, which may be adjusted by something like a prompt template. And then looking at that query, we plug it also into a search engine, which is that database of your proprietary information. And we're taking both the question and those retrieved web pages or those retrieved PDFs or those retrieved markdown files and saying, Gemini, read both of this information and create a response. Wow, they spin that in there. Okay, we're going to skip through some of this. So what we're actually going to care about, though, is that... Sorry, doing this again. The first step that we want to do is actually ensure that we curate a concept called ground truth. So what this means is that for every response that comes in from our V0 version of a RAG application, we actually have a human jump in there and say, hey, I'm going to go ahead and score the response and then write down a real answer to this and use that to compare all of the same queries that may come in from a user and ensure that we have a true answer to that. And so in this situation, what that means is if I were to ask that same question about the fluctuation of sales for a particular company, I know the true answer to that. And I can write that down in a what I call an evaluation data set and ensure that if I were to ask that same question over and over to my large language model, what we're trying to do is ensure our response gets as close to that human created answer as much as possible. And similarly, because we're actually using a RAG pipeline in the situation, so that search engine or the optimized database, we want to ensure that we're also providing the best information to the large language model. So that actually means going back and looking at what documents were retrieved from our search context and saying, hey, it turns out that in this question about Apple, for instance, we returned some Tesla documents too. That should not happen. So that's this concept of ground truth context. So there's two pieces. The piece of, am I retrieving the best documents, which is the R piece of retrieval augmented generation. And they're also generating the best answer, which is validated against a human. So that's that GAG piece, I guess, the augmented generation piece. And so it's the interplay of both of these components working together that create high quality RAG pipelines. And as a result, this also creates this variation of three different types of evaluation schemas. The first one being direct evaluation. So this is just saying, looking at the response directly, am I making up answers? Is there some type of bias that does not make sense? So without even the need for a ground truth, this is just looking at the direct response and ensuring there is no direct quality issue. The next one is called pairwise evaluation. That's when you're actually comparing the human level answer against the LLM generated answer and ensuring that both of them are synced to some capacity, be it how it sounds or even the quality of the response itself. And then there's reference evaluation. Oh, sorry, I mixed up the piece a little bit. Pairwise evaluation is about the form and tone of the response of the ground truth, the human generated version, and then the LM generated version. And then there's reference evaluation. Is the correctness of the LM generated response of the correctness of the human curated response? So feel free to drop questions in the chat if that's a bit confusing. But these are just ways to look at the response of a large language model and ensures that it's unbiased and unhallucinated. It sounds human and also is correct like a human would want it. And as a result, there's a couple ways to approach how we can do evaluation over these different direct reference and pairwise evaluations. So eyeballing is a term that you might hear a lot, which also may relate to the concept of vibe checking. So it's the way where you actually are using you as the creator of these pipelines, the AI engineer themselves, are looking at the composition of the retrieved documents and the generated response and thinking to yourself, yeah, it looks right. And so there is a degree of reliability concern for that, but it is really quick. You can actually jump in and use tooling like I showed you earlier, which is the weights and biases weave tooling, and click through and see, okay, the documents make sense and the generation makes sense. But as a human, there's that human fallacy component where you're looking at hundreds and it's easy to get fatigued and also not scale efficiently. Then there's a second component, which is the most reliable, but the most costly and slowest, which is manual evaluation, where you sit down with human annotators who are domain experts for whatever your use case is for the RAG pipeline and having them score a bunch of different responses. And then in between is this concept where alignment is useful. It's where you actually have a large language model be the proxy for you, the AI engineer who's eyeballing, and a proxy for the domain expert who just scored a response. So this concept called LLM as a judge, where you have a large language model be the human doing the work that is scoring the response for if there's any toxicity, if it is sounding like the ground truth human response, and also if it is correct like a human would want it to be. And so this is a nice graphic, which I'll leave here just to peruse yourself, which also represents how there's this the connection between how your end users are actually using your application against the quality of the evaluation itself. So in the world of public benchmarks, poisoning what large language models are able to know. Sorry, there's a question here that I want to address. So yeah, Rob Hanma, great question about initiatives to protect LLMs from being poisoned with misinformation. That's where the human piece actually comes in. So because public benchmarks tend to become part of the training data, and also there is training data that comes from unsavory sources, there needs to be a layer of human in there where you add in guardrails yourself. So where you actually go in and look at the generations, curate this human level of annotated data that represent your end use case, and then having that be a source of ground truth. So in general, having proprietary evaluation validated against yourself and human annotators is the way to prevent misinformation and incorrect responses generally for the end users who may be using these pipelines in their own interesting ways, to say the least. And so in this situation, the first thing that you have to do to actually ensure the quality of the search engine, so that database piece, is actually a bit more boring than you realize. So there is no large language model specific way here. Instead, what you see is that you have to treat this ability of the large language model to pluck documents from the web or your proprietary database like any other way you treat a search engine. You do very numerical ways of solving this. So all of these metrics I showed you here are actually ones you've been using since the early days of Google. So Google, when you initially create search engines or create databases and you want to retrieve those best information for whatever your use case, especially in the non-LLM world, these are the same metrics that you would use in the large language model world. So all of these, in a way, represent, am I selecting the best documents in the right order and ensuring I'm not missing documents, or at the same time, I'm not over retrieving documents that are unuseful. These metrics contain the whole collection of those kind of dimensions of usability, but also high quality. And so all of these, unfortunately, don't have a very interesting way of solving. It's where you just use standard assertions. You write some code that will actually look at the outputs of these documents and actually just use standard unit tests, for instance, in the world of Python, and just spit out that true or false of whether or not it matches things such as, are bullet points present? Is the document too long? Is this a valid form in the first place? Did I retrieve a PDF versus Markdown? All of those are really boring tests that are the first layer that you can do in your evaluation pipelines. The next thing you can do is use something like traditional NLP metrics. So you may have heard the phrase of Levenshtein distance Rouge scores, BERT scores, blue scores, etc. All these interesting acronyms or names of other very famous mathematicians. All of these essentially say, looking at just the words themselves, so looking at the human ground truth and looking at the LM generated response, how much overlap of the words selected are there? And there's other interesting ways to also grab the semantic meaning of these sentences. But in general, as you and I can kind of tell right now, that's a very naive way of saying whether a result is correct. The LM can generate really high quality responses, for instance, but not use the same words as something like my domain expert may use. In fact, it may be a byproduct of us trying to create simpler language than something like a domain expert may care about. And so as a result, this is where something like LM as a judge is really useful. So this is a really simple concept where you say, you provide the retrieved context from your RAG pipeline, so those documents from our database that we just evaluated on. You take the LM generated response that we think we don't know if it's of high quality or not, and we simply say to a large language model, so you take Gemini 1.5 flash outputs and you pass it to Gemini 1.5 Pro and say, hey, your little brother just said these things given the documents I provided to it for a question, for instance, about those sales markings quarter from quarter. Is it correct? And 1.5 Pro will look at those, the output, the context, and also the rubric you gave it and say, this is of low quality. I'm going to give this a score of fail. And there are ways to actually understand how to make really good LM judges. And we're releasing a course with the Google Gemini team to actually ensure that you guys can understand how to craft those. But that's going to be outside the scope of this specific talk. So I'll skip through this because that will be something we can talk about later. So feel free to scan the QR code or access the handout to access the pre-registration for how to create high-quality LM judges specifically. I'm going to use this to now answer quick questions while I have the take-home pointers on the screen. There are a few of them. So are there any developments happening to establishing standards on the accuracy of results through third-party fact-checking? I will say there are ways that folks are now ensuring that there are pipelines similar to LM as a judge where it connects to the internet also and tries to determine if there's factual information that exists in the grand scheme of the world. I mentioned the poison thing already. So in general, even though you are able to drop in whole documents into Gemini, I actually urge against it because even though there are interesting techniques to increase the context window of these large language models, there is a known research to show, similar to humans, actually, interestingly enough, that there's a recency bias and then there's a beginning bias. So like humans, when we learn information, the first thing about the topic and the latest thing about a topic are what humans remember the most. But in between, in that middle, there's a lot of haziness for mental retrieval of humans to access what we learned. That same problem humans face is actually mimicked, interestingly enough, in large language models. So this is this concept called needle in the haystack. Essentially, information that's nestled really deeply in the middle of a document is typically missed. And so there's a lot of ways to try to mitigate that, but it's quite easier to use really good chunks, so only slicing up a document into smaller pages and storing that efficiently in a database so that your large language model can retrieve only the most interesting slices typically works better and has higher quality than simply shoving in the whole documents. So viva RAG. RAG is not dead. And then broadly speaking, should more of the evaluation strategy shift towards LM evals or manual evaluations from the eyeballing approach? I think there's a time and place for each. So when you're creating that V0 version where you think you have an idea of a use case, what you'll do is actually jump in and use eyeballing to try to cater your application towards your concept of a use case. They deploy it, that V0 version of it to the world or to your own internal teams, and actually understand how your users are actually using the application. Because it actually turns out in the world of large language model or AI applications, most people use your application in ways that are unexpected and actually flesh out what your true use case was. And then from there, you can curate those evaluation data sets and then start to create that pipeline, which goes from eyeballing to manual, and then you can start creating more of these automated tests, both in the software realm and then the LLM eval world, which you can iterate on using the techniques we'll talk about in the course and outside the scope of this specific talk. And yeah, so in general, I do think RAG will still be useful until there comes a point we're able to solve the needle in the haystack problem, which is a very huge issue that happens for people shoving in pages and pages of information to these large models. Not to say these models are unable to do it, but it's actually much more reliable, for instance, to have that. If you wanted once in a while, you don't want applications that are able to once in a while find that piece of information that actually solves the question. It's much easier to make sure that you plug into tooling that grabs that information much better. Okay, so that's kind of those are the ways to iterate on transitioning a POC RAG application into a production ready one. Now let's talk about the steps you can take that you want to iterate on once you've started to create these evaluation pipelines, where you have the eyeballing set up, you have the manual evaluations pieces ready for human annotation, and then also have some automated tests for components that you think make the most sense. So be it at the retrieval part or the generation component. And so one thing that is always true is that high quality data leads to high quality responses. So how we chunk our data and how we transform each chunk into the proper numeric form that a smart large language model is able to retrieve from is an essential piece that is the core component of a successful RAG application. Without proper data chunking mechanisms and data processing mechanisms, you're going to retrieve information that's going to muddy up the thought process of something like Gemini. So that's why parsing data in very consistent ways is useful. So that means converting code so that all code is consistent across all of your Python files, JavaScript files, Go files, etc. And also a way that makes sense alongside the other forms of documents you're maybe providing. So that could be Markdown, PDF, raw JSON files. You want to make sure that you note them in ways that the large language model can say, okay, I'm looking at a chunk of code that is different from Markdown, and having nice ways to really format that, for instance. And then that naturally goes to the piece of chunking, where you actually want to go ahead and split up the text or code in ways that is not confusing to large language model. For instance, if you chunked a large Python file in a way that it does not have in the middle of a function, for instance, the large language model is going to say, I have incomplete information, so I need to hallucinate. So chunking is a way to actually initially mitigate the need for a large language model to, for instance, make up information. The next is metadata management. This is useful from the retrieval side. So like all good search and all performant and useful search engines and databases, you're applying proper metadata, so you're able to actually retrieve information in ways. So sorry, let's go back here still. In ways that don't require you to only rely on this fancy embedding-based approach that serves as the core of semantic retrieval, as they call it. AKA, if you ask a large language model, I only want documents from 2021, you don't want a large language model to go in and essentially take documents that may reference 2021. You want to simply say, okay, I'm going to filter on 2021. That's kind of reiterated here. So in general, you want to clean and extract, convert to plain text, and then mark things efficiently. You want to segment text in the ways that make sense. And you want to create representations of those chunks in a vectorized form so you're able to retrieve this extremely performantly. So for those of you confused about semantic retrieval, it just means that when a user asks a question, you can turn that question into numbers. And then similarly, for each chunk document, those are also stored in a numeric way. So that what you can do is say, hey, my question, which is now converted into numbers, only retrieve documents that also have a similar looking number schema, for instance. Let's skip this, it's fine. Yeah, so that's the one component where you can ingest documents properly. And so as you change how you chunk things, how you embed information, and how you have appropriate metadata, you want to plug that right back into your evaluation pipeline where you're eyeballing, manually annotating, or using some automated approaches and seeing if your score goes up, for instance. Next thing you want to do, possibly, is actually understand if your users are asking the right questions. So this is the concept of query enhancement. So what's really cool with large language models is that large language models can actually go ahead and read a user question, and then you can ask the large language model to say, this user, if this question does not make sense, upscale the question in a way that I'm able to retrieve better documents. So for instance, let's say I stored my documents in a really interesting format and have really interesting metadata in my database. What I could do is actually ask the large language model, hey, given I have this metadata on the documents in my database, when a user asks a question, give me the best filters to use to grab the best documents. So you can actually shove in an additional piece where you ask a large language model before it even touches the generation piece to say, let's go in and use our knowledge of how we're storing this information to ask better questions to our database in the first place. And so there's a couple ways to do this. And these are the 4 steps I recommend. So conversation history utilization is a way where you actually summarize, for instance, in a multi-turn chatbot, where a user may be asking multiple questions. You can say at every new question asked by a user, hey, before answering this direct question, summarize the previous conversation. That's what you'll see a lot in a lot of these modern chatbots, for instance. The second one is intent recognition. That's where you actually ask the large language model to read the question coming in from a user and understand what the core category of question is. So like in the case of finance, what you may have is a user come in and ask questions about how are the financials changing quarter from quarter, for instance. And so for that one, you can have a category called financial analysis, which may be different about some other categories that may exist. The next one is keyword extraction. So if, for instance, if you know that there's a presence of specific phrases that you have in your database that you're filtering on, you can actually ask the large language model to extract out important keywords from the user question itself and use that to pre-filter stuff from your database, for instance. The next one is query decomposition. This one's really interesting in that what you can do is also ask a large language model to look at a question coming in from a user, and if it's a really complicated question where it's actually like a running paragraph, for instance, you could ask the large language model to go in and decompose that question into 3 or 4 questions and then iteratively solve that problem. So you can say, take question 1, plug it into my RAG pipeline, solve that, use that as context to the next question, and then as a result, even though it's a little bit more costly, where you now have decomposed 1 question into 4 questions, each response that have touched your RAG pipeline is of extremely high quality, and you're able to also better debug where a thought process may have gone wrong from the end user asking that complex question to your initial RAG pipeline. And so things such as structured outputs is really useful. So in the Google Generative Gen AI SDK, for instance, they have really nice ways to spit out JSON, for instance. So you're able to go in and ensure that you're always getting the keywords that you want, or decomposing the questions in the number of questions that you ask of the large language model. And so I'll be sharing the deck later, so I'll leave these for you all to look at, because I do want to talk about the really interesting one, which is also re-ranking. So this one I find really fascinating. So there's this concept, as we just been talking about in RAG, where what you're doing is you ask a user asking a question and you retrieve the most relevant documents. But sometimes these documents aren't actually that useful. For instance, oh no, I need to rebuild this real quickly. Cool. So for instance, depending on what algorithm you use, there's some sort of fallacies in what documents you're retrieving. Sometimes the user's asking questions in a way that does not match the way that the document is formed, for instance. So in the world of our customer service chatbot, for instance, you may have documents from your marketing pages and you may have documents from your FAQs. So a user is going to ask a question that sounds closer to FAQ, but the information is better suited from our marketing site, for instance. So what's going to happen is, because the question sounds more like a FAQ question, we may never retrieve documents from the marketing site, even though the user may be asking a specific question about pricing that's only found on a marketing site, or about partnerships, which also is better found on a marketing site. And so if there's verbiage or language that is misaligned, there's a big problem with that in the world of this retrieval portion. And then also in general, depending on how big your document is, if you didn't chunk it properly, you may have stored a document that actually misses the point. So in like the marketing portion, if we were to shove in our whole giant page with our partnership about Google, it may not actually get the pieces that separates our foundation model builders versus our Gen AI application builders, for instance. And so that also is another component of retrieval that typically fails. So query translation is something we just talked about right now. That's really useful for actually solving a big portion of this, where you actually get to the point of what the user is asking and ensure you decompose that user's question in a way that plugs in better to that database. There's also there's other component of metadata filtering, which I've been talking about, where you actually also use that query decomposition to understand that users are only asking questions about 2021. So only retrieve documents from 2021. But I think is really cool is this concept called re-ranking. So you actually want to do is, rebuild this real quickly. Cool. What you actually want to do is you're going to grab all the documents that make the most sense, and then you're going to run it to a different model. And this model is going to look at all of the question that just came in from the user and these documents and say, all of these documents, while supposedly is useful in the order I got it, let me just in case switch up the order so it actually is not redundant and also is useful for what the user is actually asking given only those 10 initial documents I was provided. And then you as a user, as an AI engineer, can go in and iterate on how many documents are actually useful after re-ranking. So in this graphic here, the yellow represents useful documents, while the white represents unuseful documents. And so let me actually go back a slide again. So that issue with needle in the haystack I mentioned earlier is also a problem with RAG pipelines too if you give too many documents to something like Gemini. So this happens because anything that's in the beginning portion of the collection of documents provided and the ending portion are what's going to be utilized. So if you don't re-rank efficiently and ensure that all the useful information is at the top of the context provided to Gemini, then Gemini is going to miss the middle information, which you can see from the yellow before re-ranking, that would have been missed because it was in the middle. Now in this situation, because we cut off to only 5 documents and all of them are now nestled towards the top, where actually in the middle is the useless document, then Gemini is actually better able to understand how to respond to this question because we made sure that it first saw that useful information. And the way to validate that, also again, is to use tooling such as your own score, your own search engine-based evaluation metrics. So that NDCG, that precision recall, that mean average precision, what I showed earlier, that's where these search engine, much more boring non-LLM scores are useful. Because at the end of the day, this is search engine optimization. Yes, so yeah, I've kind of mentioned all this stuff out loud, just so you can have the deck to look at this. And lastly, once you have properly ingested data, you have properly chunked documents, you decompose queries effectively, and you're re-ranking properly, now it's where you actually go and look at the more LLM-based stuff. So only until those initial steps are done is something like prompting useful. And so this is actually fairly straightforward. All of you are probably doing it right now with your own chat applications, where you go in and actually formulate your inputs in a very structured way. So writing context in the beginning, providing instructions to your large language model, defining the task that you actually want, and then at the very end, providing a refined question to the large language model. And so there's this natural loop that occurs. You test out a new prompt, you plug it into your RAG pipeline, you look at the score, you see if that score increased, and then you try it again. So at this point, this is where a lot of your automated approaches are most useful. So everything I mentioned previously, that's a little bit more manual, a little bit more human annotation, and a little bit more eyeballing because it's standard software. You're optimizing search engines, you're optimizing input user queries. But instead, now what you're trying to do is optimize answers. So you're at a point where you now curated useful evaluation data, you know what to eyeball for, and you now create LLM as a judge and automated software tests. So that's where this loop is a lot more quick, I would say. And so a best practice, I would say, is to ensure that you provide high quality examples into your actual response itself. So maybe even having portions of your evaluation data set in the prompt provided to a large language model, which is slightly different from a user query, because a user query is simply a question. A prompt is what you shove your user's question into that has examples of best responses given that user question, and it has really strict instructions about how to solve an answer. Once you have all of that nicely formulated, you can consider things such as, what are the best examples to provide to my large language model such that I'm able to make it sound more human. And so there are a lot more interesting and vigorous techniques that exist, for instance. I'll leave this as a deck portion to read through. And if you are interested in how to create more streamlined evaluation frameworks, I'd recommend signing up for our course that's coming up soon with Google, which talks more about evaluation. I do want to give some time to answer maybe like a question or two if people are still chimed in. So I'd love for you to ask questions in the chat box here. Thanks for listening.
Yeah, that was awesome. So much great detail on how to improve RAG. There was a question from Alejandro who said, you mentioned at the beginning Gemini is able to ingest all the documents directly. With the progress in LLMs to increase their context window, will RAG still be a useful tool in the future?
Yeah, so like I mentioned earlier, I do think that there are fallacies with the context window argument in that information is spread out through many documents. And so the core thing about RAG was not just to get around the context window problem. It was always to ensure that the best portion of information was available to your model during the time. So there's two things you're saving when using RAG. One is you're using less tokens because you are billed by token still. We live in a token economy. And two is that you're only ensuring that the best portions of information after all of your complex RAG components are in place are provided to large language model. So it's not missing any context because you took the extra consideration to ensure only the most effective portion of context is available.
Okay. Hey, and you mentioned, all kinds of, pitfalls that people can work around. What's the most common pitfall that you see when productionizing RAG pipelines?
Yeah, great question. So I do think that the common pitfall I see from most folks is that they jump into the solution space without first evaluating or investigating the pipeline to understanding their use case. So in the RAG world, most of us can actually go right now, pull a GitHub repo, shove documents into whatever the point and click no code version there is, or the code version there is, and create your own RAG pipeline. But without an iterative approach to actually say, these are of high quality responses, then what you're actually doing is releasing something that can cause users to easily maliciously use that application. And for instance, gain access to proprietary information in that database that you just curated for them. So in general, not having a evaluation-driven approach is usually what I see as is a problem with people developing these RAG pipelines.
Fantastic. All right. Well, Anish, we're just about out of time here, but thank you so much. This has been a great presentation. I feel like we're right on the cutting edge of of LLMs and RAG. Really appreciate your talk today.
Thanks for having me.
All right. So I'm going to let Anish go there. We do have one more piece of business, and that is the prize drawing. And if you didn't grab that QR code, that's still in the handouts, the opportunity to sign up for that evaluations course. Looks like great stuff there. But as far as the Amazon gift card prize drawing, the winner of the $250 card today is Pierce Muncie from Pennsylvania. So congratulations to Pierce. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank Weights and Biases and Google Cloud for making this event possible. Thanks, as always, for attending and for all your great questions. That's going to conclude today's event. Have a fantastic rest of your day.